Well, on the bench today we have another Cobra 200 GTL DX, and all I can say is, another one. And I don't mean one of these radios, I just mean another one that's been hacked at. It's not so much hacking, it's just bad repairs. People just, And how many times I need to say it? If you plan on working on surface mount equipment, practice. Practice, practice, practice. Don't just jump into something like this thinking you're going to take granddad's soldering iron and become a surface mount component soldering whiz overnight. It doesn't happen. Buy some cheap made in China practice boards. They don't even need to be listed as a practice board. You can get little kits. They're like $1 or $2 a kit. It's a circuit board, comes with all the parts. Practice soldering the parts on the board, and then in most cases where damage occurs, practice removing those parts. Once you can safely install and remove parts off of a cheap junk Chinese circuit board without damaging the circuit traces on something cheap, then you can move on to radios. And why do I say this? Because this one has damaged circuit traces. Again. It's getting to the point of, because this is, I don't know how many in a row. This is like the third or fourth radio in a row where I'm doing repairs to damaged circuit traces in a surface mount style radio. So let's have a look-see. Let's get some overhead lights. So, like I say, this is a Cobra 200 GTL. This one, the faceplate, that color, that's actually what it looks like in person. It's not the camera or anything. Yeah, it's supposed to be silver. I don't know. It looks like tea or coffee stained. I don't know. Yeah, it's falling apart. Luckily, the customer sent along with the radio a brand spanking new one. So, yeah, these are getting hard to find. So, because this does have the backlight, the illuminated backlighting, which was a huge downfall on Cobra radios. I really hate this stuff because it just doesn't last. But he has a new one, so this one can be saved. But the customer said there was a problem, apparently with low output power or something in the final driver section. And yeah, sure enough, somebody had been in here. I've already gotten it torn apart. As you can see, there's the shield that would have originally been right here has been removed. I had the driver MOSFET out of it, and I probably should have started a video there. It was just, yuck. But try and get the light so it's not reflecting too bad here. There we go. It's not too bad. But yeah, there is supposed to be a circuit trace right here that comes over to here, and there's a small, and it's actually somewhere here on the bench. There it is. And this may have been part of the problem. This surface mount resistor, here flipped over, that little guy right there, the solder connection tab, because you have to remember it's basically a piece of ceramic material, has some resistive material added to it, and then a coating over top of it, and then it has solder, basically caps on either end. There's little pads where the component actually gets soldered down to the board. It's basically ripped off one side, and it's stuck to my pointer there. But, so that entire circuit trace is just gone. And it was broken off from this side. The lead from this MOSFET was bent over for a reason, because there was no trace, and they just kind of had it bodged onto there. So I don't even know if it was even really in circuit. It's supposed to be in series. The power that goes, because that's actually the flow of RF into the drivers through the ceramic capacitor, then through that series resistor, it's 22 ohms, and then goes into the MOSFET. Yeah, I think it was about half bypassed with the bodged up solder that was on there. But yeah, I've got to install a new trace here, so I'll have to cut one out and get that glued down to the board or epoxied down to the board. The center one's fine. I think the only reason that it survived, as you can see, it's just completely filled with vias. So this is, it's stitched. As you can see, all these little holes here. What those do is connect the circuit trace on the top side of the board to a circuit trace on the bottom side of the board. That, I think, saved this trace. They didn't heat it overheat it with a soldering iron and unbond it off of the fiberglass material. That's what actually kept this trace down, was all of those stitched vias right there. However, this one, again, didn't survive. As you can see, I can lift it up. It's just flopping around. But it is not cracked or ripped at all. So it's still there and it's still fine. So I'll be able to just put some epoxy underneath of this circuit trace and then clamp it down. And that trace will be fine. And then, like I say, I'm going to have to just cut out a new trace to fit in here, a little one, big pad here, and then a little ear that sticks off to the side. But yeah, this is just, like I say, just another radio that just goes to show. And it's not that surface mount soldering is really that hard. It's just, and I don't want to I don't want to discourage people from working on this kind of stuff. It's because honestly, it's not that hard working on surface mount components. Now, they're small, don't get me wrong, and they get smaller than what's in this radio. Most CB and even amateur radios, 0402 is probably about the smallest size you'll see. 0603 and 0805s are probably more common. But it's just you have to practice. I did not, when I first started working on surface mount stuff, I quickly learned, I don't know what I'm doing. I took the time and researched it. Spent time investigating what equipment did I need, different fluxes, solders, how to do it. The main thing was practice, because it's just soldering. It's not that indifferent from soldering something like this capacitor right here, which is a through-hole component. It's just, you really need to watch your tip temperatures, because if you get it too hot, the traces are so small, it's very easy to do what they did right here, delaminate the traces off of the circuit board, causing damage. And in the case of this one, because it's not connected to anything else, it just, it was ripped off and it's gone. But you watch your tip temperature and use appropriately sized soldering iron tips. And I think that's part of the problem here. They probably used something like this, or similar size. A big honking tip. You don't want a big honking tip. Where'd that little resistor go? I don't know if I can find it anymore. Stuck my finger here. Come here, little guy. There's the resistor. There's a soldering iron tip. Do you think this tip would be a good idea for soldering a component that size? No. You want something like this. A little teeny tiny tip. It's more appropriately sized, for the component that you're soldering. And that's actually looks a little bit bigger on the end than it actually is, because there's a little bit of solder on there. But that's what you want, a very small tip for doing very fine soldering. It's just mainly attention to detail. Take your time, but practice, practice, practice. I just can't it's like anything. Just working on electronics, period, you need practice. You can learn all the electronics in the world. If you never do it, and then you come back years later, you will have forgotten pretty much everything you ever learned about it, because you're not doing it all the time. Hands-on experience, there's nothing beats hands-on experience. But like I say, just spend a couple dollars. It's not going to bankrupt you. If you're going to work on this kind of stuff, get a couple little, flashy LED kits or just little practice boards. You get them on eBay, Amazon, good grief, the internet's filled with them. And like I say, they come with all of the parts. And if you get the little practice boards, they come with more than just resistors and capacitors. They come with integrated circuits. So they'll come with quad flat pack or dual inline package stuff like this, components, and you can practice on stuff. Then when it comes time to work on something like this, you don't end up doing that. So let me get to it. Like I say, I got to bond the one down, cut out another trace to replace that one. I'll test this, but I get the feeling I'm probably just going to be sticking a new one in. As dark as this tab looks, it looks like this thing got rather hot. The screw for it was extremely loose. Actually, the screw for the finals, I tightened them up. Man, they were, if you'd have shaken this radio too much, I think they'd unscrewed and fallen out. I'll test this, but I've got a whole drawer full of these blasted things. I'll probably just stick a new one in. It's better to be safe than sorry. And hopefully, once I get that in, it'll be okay. I'm hoping. Nothing looks dark or burned over here. It doesn't look like the finals ever got overheated, and it's usually not too hard to tell because they'll start to change color. The ceramic buttons, they'll usually start to get dark. A lot of times you'll see the resistors burned up and whatnot. Yeah, nothing looks like it was overpowered too much. This looks like maybe they had a driver problem and they screwed the pooch on that repair. Woo. I think they may have caused a short there, and yeah, so I may have voltage regulator circuit problems if they did, because it kind of looked like some of the leads might have been shorted together. They may have fried something in a voltage regulator circuit, but yeah, I think the amplifier circuit probably survived fine. So let me get this fixed up, and we'll see if it works or not. Okay, so I thought, because occasionally I get questions about how I do trace repairs, and most of the time when I do them, you'll see the before and you'll see the after, but you never see much of the in-between steps. So to create a trace, now I have packs from Pace, from Circuit Works. I've got circuit repair kits, okay? They're good. Now I can even do like through-plated holes. Or like through-hole components, where there's the through-plated holes. I have what they call funnelets. So you actually would drill out the hole, and you install basically a little small tube, you swage it into the hole and then solder it in. There's just hundreds of different angled little traces, but you can cut them out. Some of them have a bonding material on the back of them, and you can actually heat laminate them onto the board. But when you get to oddball stuff like this, if it was just a finger, just one rectangular little piece, yes, I've got those pre-cut already from some of those companies that make them, and I could just cut one of those out to the proper length and stick it in. The problem is it has the little ear that sticks off to the side, so it's kind of unique. You're never going to get that in one of those little pre-made circuit repair kits. And besides that, those kits can be expensive. The one master kit that I have, I think that was the Circuit Works one. That's like I think it was the Pace master kit. It's over $1,000. Even the Circuit Works one, I think that's over $1,000 for their master through-hole and surface mount repair kit. But you can get away with nothing more than a couple basic hand tools, razor knife included, and some copper foil. So that's what I'm using to repair this one. Now, if you were replacing one of these circuit traces here, and you didn't have one of those kits with a nice little pre-made traces, you could do the exact same thing. Do exactly what I'm going to do here. Just take a piece of copper foil, which is a piece of, it's kind of like aluminum foil, but it's made out of copper. Very thin. And just cut it out with an X-Acto knife, razor knife. That's it. Really nothing special. Now, I've found the easiest way to do this is, for starters, you're dealing with stuff that's really small. So do yourself a favor, take your big sheet of copper foil and cut out a little small chunk. Just take scissors, cut out a square, and then tape that to a piece of glass. Now, I got a bunch of these. I think these were lenses for a light or something. Might have been flashlights. I don't know, whatever they were. But they're tempered glass, and I got a bunch of them. The only thing I use them for is mix epoxy on them, and they're also great for cutting stuff, because actually glass is very hard to scratch. So I just take my piece of copper foil, take a piece of Scotch tape right over top of that piece of copper foil, and then just proceed to cut out the trace. Now what I do is, I'll start out with, I know I'm going to have a right angle, so I can just lay the roller on here, basically like exactly what I did on this one. I just started out like that, made a cut along, and just use a little small machinist roll like this. It doesn't have to be Snap-on, Brown and Sharp. I mean, you go on eBay and pick these things made cheap in China for next to nothing. But just laid that on there, made a cut and a cut. That gave me a perfect 90-degree angle. So, that gives me, say, this edge and this long edge on the right. Then I can measure down from the edge here down to this little ear that sticks off to the side. And to do that, I just use, because there's no way to get a roller, down in here to be able to actually take measurements, I just use a compass. So, to get my distance from the edge of the board here down to the beginning of that little ear, got my distance, come back to my little piece here, transfer that distance on there, make a cut, come down to the other side of that little ear, same thing, measure the distance, come to here, make a little cut, measure the overall length, the whole thing, and I've got it pretty much all cut out here now. So there's my little, never get the reflection right here where you can see it. I'll just pull it off. See if I can get her popped out of here without ripping any of the ears off of it. Do this with the camera is a bit of a chore. Okay, I think one just not quite cut far enough there in that one little corner. And that's another thing, when you're doing this, it's always better to undercut than overcut. If you cut too much, it's kind of hard to put back. If you don't cut enough out, you can always come back, retape. There's my little repair piece now. You know, if this for some reason is too long in one direction, and I know I'm going to have to probably trim the end of this ear off. I kind of just oversized it a little bit. But if it's a little bit too big, that's no problem. I'll just, take this off, put a new piece of Scotch tape over top of this little guy, and then I can trim it to size. Don't try to do it freehand. Well, you're going to be doing it freehand, but don't try to do it, I guess what I should say is, don't try to do it without having it taped down to the glass, because if you try to hold this like with your fingernail or something, and while you're cutting, you're probably going to end up kinking this thing, or it'll move on you, and you'll end up, and then you'll be all pissed off and you'll have to start over again. If you tape it down, that prevents it from moving. That's why I always Scotch tape it to a piece of glass. Works really well. So, and now, when I'm satisfied that this is the correct size, it's the perfect repair for whatever I'm doing, you have to remember there's now also a piece of Scotch tape stuck to this, the side it's facing up right now. There's still Scotch tape on there. So I'll just drop that, on the bench, put it, or actually I'll just do it on here because glass solvent resistant, and I'll just put a couple drops of that, like acetone, you can use anything, but something to soften up that glue, and then I can peel that tape off of the top of it, clean it up really well. I want to take a fiberglass brush and burnish both sides of it so it has it's good surface contact for soldering on the top side, and I want to roughen it up as well so that the bottom side, when I epoxy it down into this place right here, that it has a good bond to the fiberglass circuit board. Because the whole plan here is, when you're done your repair, it should be just as durable and just as good as the original circuit trace that was originally on the board. So, let me set that to the side there. Grab a pair of tweezers. Take my little trace. Come here, little guy. And it just flipped over. And another thing is, most companies, when you get this copper foil, one side, you can see how it's kind of like almost brown, where this side is more copper looking. This side is actually, if you look at it under a microscope, it looks like it's sandblasted. It is a very rough texture. When you're taping down, actually that'd be the best thing for me to do. Let me just set this little guy down here. I'll just untape this. Oh, for Pete's sakes, get off of there. Scotch tape never cooperates. There we go. But you can see, peel the tape off so you can see a little bit better. So you can see how it's nice and shiny on this side. This is the side that you want facing up. This side is texture. If you run your fingernail over it, you can feel it. It just has a really rough texture. This is the surface that you want to stick down. The reason you want to put that down is because, like I say, you want to epoxy this down to the circuit board. So you want it to have the epoxy to have something that has some tooth, that's a fairly rough texture, so it gets a really good bond. So like I say, always make sure but you still want to clean this. Even though it's, it's new, hasn't been used, it's still, the instant this stuff was made, it oxidized. I mean, literally, it just is, the instant air touches bare copper with a little bit of moisture in the atmosphere, this stuff oxidized. It may look nice and shiny, but it's not as shiny as if you clean it. So, that's why I say, reach over here and grab a fiberglass brush. You can come in here. You can see how much shinier that is, and even on this side, it looks nice and shiny. If I come in, you can, I come in with the fiberglass brush, it makes it even shinier, and it's hard to get with the reflection of the light here, but it is shinier in that spot where I just went over it with the fiberglass brush. So, where did my little trace go? There it is. Griefus. cut this little guy out and I sat it down, forgot where I put it. So now, like I say, I'll just set this down in here. If it doesn't stick, I think I've got some flux residue on the end of my tweezers here. A little bit of isopropyl alcohol. Clean them off. So let me move the camera back because I can't even see what the heck I'm doing. And the light, trying to get this so it's not too much blinding the camera. Like I say, you just want to test, basically a test fit. Get this little guy, come on, move over. Oh, for Pete's sakes, what is there? A piece of fuzz in there? It's stuck. Okay, and that looks pretty good. Okay, got the edge there. Put the little finger. So yeah, now I can see I do need, because all of this surrounding this trace here is ground plane and we don't want that shorting out, because remember, this is the input into the driver MOSFET there. I know why this thing's hanging up, because the Scotch tape's still on there. I can see I need to trim a little bit off of that corner right there and a little bit off of the bottom, because I don't want it to touch these ground planes anywhere around here. But yeah, I'm happy with that. I just need a tiny little trim there and a tiny little bit of trimming on the bottom side. I'll put a little bit of solvent on there, get that piece of Scotch tape off of it. Then I can clean it up, mix up a little bit of epoxy, glue this trace back down, glue this one down, and now I'm going to want to clamp that as well. So the easiest way to do that, and because there's really no way to get, ideally, if you were to take like a course from Pace soldering equipment, you take one of their courses, they'll show you what a circuit board with a spring-loaded clamping fixture to hold down. Yeah, in the real world, we're not going to take this circuit board out of the radio. It's just not going to happen. It wouldn't be cost effective. If I had to disconnect all of the wires off of this, take the heat sink, which is also the entire back of the radio, desolder parts off of it, to get this circuit board out so I could get a normal little spring clamp in there to hold down on it. We're not going through all that. What I will do is, I'll put epoxy on there, I'll get it where I want the parts at, and then I'll just take a piece of polyaramid tape, Captain tape, something like this. I'll just take a piece of this and carefully lay it down on top of that, and then I'll push it down so it's tight down against the board. But I'm just going to use tape to hold it down until the epoxy cures. Once the epoxy cures, I can then peel this tape off. Done it a million times before, and if you've mixed your epoxy properly, the epoxy won't stick to the adhesive side of this tape, so it'll easily pull off. And like I say, if you mixed your epoxy properly so it actually does set up and gets hard, you will not pull the trace off of the board. Actually, if you do pull the trace off of the board, that's a good indicator that you didn't do something right, so you'd need to start over again. But that's just a little bit more about how I go about doing this. So let me get this little critter pulled back out of here. Like I say, I just got a tiny bit of trimming left to do. So just like I said, I'll tape that back down to this. Actually, I'll take that piece of tape that's on there first off, so I don't have two layers of tape to remove, but I'll get that piece of tape off of it, retape it back down, make my little fine-tuning cuts on there, and then I'll be ready to stick it in. And once I get it actually stuck in there with a little bit of epoxy and I get the polyaramid tape over top of it, I'll show it to you again. Now, sometimes, and I may try, I've got big spring clamps and C-clamps. If I can get something in an actual clamp to hold good mechanical force down on it, I will. But you just have to, sometimes you got to live with it. It's impossible. There's just no convenient way to get a clamp in there. Like I say, I've found that just taping it down works good. Just make sure when you tape it down, take the end of a screwdriver or something like this, that you will actually fit in there. Just push down and push it down so it's really tight down to the board. it usually is just fine. And then to speed up the curing process, now I'm not going to stick this whole radio in my curing oven. So what I'll do is I'll just take a hot air gun. I've got a little swing arm here. It's got a clamp on it that I can just attach my hot air gun to it. And then what I'll do is just locate that several inches up over top of the board, blowing hot air down onto the board here. That way I don't have to wait, all day for that stuff to cure. Epoxy cures faster when heated, and if you look at the data sheets for whatever epoxy you're using, it will show you what the curing time is if you do it at an increased temperature. So it'll say at 150 degrees C, let's say, it'll be cured in 15 minutes or 20 minutes. So instead of having to wait 24 hours to do it at room temperature, in 15 minutes flat, I'll have it cured. So I shall return. Okay, so I got some epoxy on there. I got my repair piece in there. Put some underneath of that trace that was lifted. Put a piece of and this is one of those things, like I say, just kind of depends on each situation's a little bit different than the other. So you got to come up with a way of holding that down, while the epoxy cures. So actually what worked out best here was I did put a piece of polyaramid tape down, laid it down on the board, then I actually went down in the hole where the MOSFET sits, sliced the tape, cut it along the backside, and I was at the roller just conveniently is exactly the same size as the cutout in the board. So I was able to fold the tape down over the edge of the board and then push it down almost back up under the board this way with this roller, so that's holding really good pressure down on there. And when I push on it, I can't see the trace moving at all, so that means it's held down fairly good. So now I'll just stick my heat gun over top of this, cure it, and actually I looked at the data sheet for this. If you cure this epoxy at 212 degrees centigrade, the curing time is 10 minutes. Now usually I won't turn the temperature up that high. I'll go like maybe a maximum 140, 150 degrees C at the most. I'll just take a thermocouple sensor and stick it down. Just lay it down in here so I get a half approximation of what the temperature is, because I don't want to go blowing up electrolytic capacitors or anything. And usually actually what I'll do is I'll take a piece of aluminum foil, lay it around some of this other stuff kind of as a heat shield, so the heat is centralized exactly where I want it, but not where I don't want it. So let me do that, then I can get my tape out of there. Now, you're going to get some epoxy squeeze out. It's guaranteed it's going to get on top of the traces. Just wait for the epoxy to cure. You can come back in with something like the tip of this and just scrape it off. It's easy to get off on the top side. It's just a really, really thin, ultra thin layer on there. You can just scrape that off. Clean the traces up. Then I'll install a new MOSFET, because like I said, I'm not even going to try to reuse this thing. And stick a new resistor in here. And we'll see if this critter works. Okay, so I've got the epoxy cured, got everything cleaned up, got a new MOSFET installed, and it looks a lot better than it did before, especially since it was completely missing, focus, there we go, since it was completely missing a trace out there on the left-hand side. And there's our resistor that, like I say, the end cap there was kind of ripped off of one end, so I'm not sure. There was so much flux and solder blobs in here, it was really even hard to tell what the heck was going on. But, so, let me get the dummy load attached to this thing, get the power supply hooked up, and we'll see if there's any life and if power has come back. And yeah, like I said, I didn't want to stick this back in. This looked rather dark, like it had gotten really hot. And then when I went to reinstall the hold down screw with the insulating washer, I got to looking at it. It's melted. Hard to see. If I can get the camera to focus on it. You can see how it's all mushroomed out on the end. Yeah, it got so hot that started to melt. Yeah, it takes a lot of heat to melt one of these things. These things are designed to be in contact with transistors, so yeah, it had some heat going there. You can really see it there. Yeah, so, yeah, I'm not even going to bother sticking that thing back in there. Even if it tested good, as hot as that thing's been, yeah, be my luck. I'd leave it in there and the customer would get the radio back, and 5 seconds later, poof, it would go out. So, and then they'd have to ship the radio back to me, and yeah, just shipping the radio back to me one time would cost more than that MOSFET cost. So yeah, it's just better to stick one in there. They're only a couple bucks. It's not like they're expensive like the pills there. So, in any case, let me get her fired up and see if it actually has some output power now. Okay, well, it looks like that fixed her up. She's got good output power now. So, anytime you do something like this, if you're installing like a new pre-driver or a new driver, before you go screaming into the microphone or cranking the AM power up, make sure the first thing you do is adjust your bias current. So I have done that in this. This has 2 jumpers in here. You either remove one or the other. Install your amp meter in series. I just had a little pigtail made up here because it's a common pin spacing. Just install that. Set your driver or your pre-driver and driver bias. Then I switched over to AM, and actually the power was way too high at the time. But if we look at the watt meter over there, and I have the radio in high power, you can see we're at 32 watts. Well, you may not be able to read the digits there, but you can. It's 32 watts, and then if I switch to low power, see we don't have much needle deflection at all. Let me switch to the lower scale. So that's a 20 watt scale now. Okay. Actually, that one was fine. That one's right at 4 watts, which is where it's supposed to be. So, yep. So this radio is definitely worth fixing now, the rest of the way. You don't want to ever get too far into repairs, especially when you see stuff like that, till you know that it doesn't have other serious problems. But since that's fixed now, customer basically, same as I did, because I just actually did another one of these radios for him a while back, and he said he gets a lot of compliments on that. And a lot of people want to know, what did I do to it that makes it sound so good? I set it to what's in service manual. It's not hard. Here's actually an original one. This is actually sent by Cobra originally. But yeah, that's all it is. Just do a proper factory alignment. Don't go cranking the modulation. Actually, the AM power, once I got that in there, it was high, but it wasn't that high. It was at like 38 or 39 watts. It's supposed to be 32 watt AM carrier in high. But yeah, I see people set these radios with just ridiculous levels, like 50, 60 watt AM carrier. They'll disable the AMC and the ALC circuits in these things, and then they want to know why stuff like that happens. Drivers blow out, more expensive, finals burn out in one of these things. These radios honestly have a horrible track record because the majority of them have been screwdrivered. People crank the power up, disable the limiters, and they're not worth whatever the heatsink and the sides are worth in scrap aluminum, that's what the radios are worth, because they don't last. If you set the radio up like the manufacturer designed it to be set up, they made the radio. If anybody knows how to set the radio up, it's going to be the people that made it. Just do a factory alignment on it. This thing will talk for years. You won't have problems with it. If you need more power, buy an amplifier, for God's sakes. That's what they're meant for. So, and actually that's what this customer does. He drives a high drive amplifier. So, but in any case, let me get the, actually I'll probably just end the video here. Like I said, I wanted to show that. The only thing I really have left to do for the repair is put the shield plate back in. I just didn't want to stick that back in until I knew for a fact that like the pre-driver was okay and there weren't any other problems in this circuit. So now that I've verified it works, got good output power, AM, FM, CW, upper and lower sideband, I'll go ahead and stick the plate back in. But yeah, I'll just stop. I've done videos on these radios before. So I just wanted to show the repair. Like I say, some of the ways of how you can do trace repair. Like I say, you don't need to go out and spend several $100 or $1,000 or more on a circuit trace repair or, a PCB repair kit. Half of what you get in that thing's a blasted soldering iron and, some epoxy and tape and razor knife. And, well, a lot of it you probably already have. So, and the copper foil, before you ask, Mike, where do you get your copper foil? eBay. Just go to eBay and type in copper foil. There's lots of companies that sell copper foil. Just try and, now, I have the copper foil in several different thicknesses. What I'll try to do is usually on something like this, most radios, at least CB 10 meter export style radios, the copper plating on these boards is pretty much the same on all of them. So, but like that trace that was lifted up, I could easily get in there, let's say with a pair of calipers, measure how thick that trace is. And what I want to try to do normally is try and use a piece of copper that's the same thickness as the copper that's already on the board. Usually most circuits in radios like this aren't going to be affected if it's thicker. You definitely do not want to go thinner, especially on thin traces. If you get too thin with the copper material, you may blow the trace out. Because if it's a narrow trace to start with, and you go reducing it in thickness, it may not be able to handle the current that it's required to anymore. So you want to use at least the thickness of what's in the radio. But like I say, you can get a couple different thicknesses. You can get it on eBay. It doesn't cost much, and you can get small packs of it. It's not like you need to buy 5,000 square feet of it. You can get like 1 or 2 square feet. And for the average person, if you're just tinkering with your own stuff, that'll probably last you the rest of your life. I mean, a couple square feet lasts me, honestly, for years. And I do a lot of circuit trace repair, but it doesn't take much when you're fixing stuff. And just take your time. Epoxy, I've shown before, it's Circuit Works is who makes that. It's the Circuit Works epoxy overcoat is what I use. A 2-part epoxy. Comes in little syringe tubes. Just follow the directions on that. And like anything when you're doing repairs, clean, clean, clean. Make sure everything is clean. In between steps when you're doing stuff, clean it off with isopropyl alcohol. Definitely before you glue anything down with epoxy, make sure you clean all the surfaces with isopropyl alcohol. You want to make sure there's no contaminants in there that are going to affect the bond of that epoxy. And you won't have any problems. What's the worst you're going to do, especially when you're cutting out a trace? It doesn't fit. Just cut out another one, and again, practice makes perfect. You'll do the first couple, they're probably going to look horrible when you stick them in there, but take your time, practice, just like with surface mount soldering, practice. Try to keep your dwell time, or the amount of time when you're soldering something, keep it to a minimum. Don't crank your tip temperature up too high on your soldering iron, and probably most importantly, reach over here and grab it, use a tip that's appropriately sized for the parts that you're soldering. If you're soldering in something like these circuit boards that stand up on the end of the binocular transformers here, yes, you'll probably want to use a big fat tip. But if you're soldering an 0603 size component, or an 0402 or something, you're going to want a teeny tiny little tip. So size does matter sometimes. So I hope some of these tips may help you out. Let me get this thing finished up so I can get it back to the customer. Tack a little piece on the end so you can see it completely done now. The transceiver alignment's been done on it. As I said, transmit power came back fine. It's set at factory levels, just like the service manual calls for. So 4 watt on low power AM, 32 watt carrier on high power, 12 watts sideband low power, and 100 watts sideband high power. So, and it will last for a long, long, long time. Can you get more watts out of it? Yes, you can. And if you like changing parts, have at it. Turn your power up. But like I say, use them as they're designed to last a long time. Crank the power up on them, and I guarantee you're going to be repairing them all the time. I wanted to show it because I got the faceplate decal installed, so you can see the backlight illumination is working. Turn it down there, and yeah, this has a weird way of doing, has steps for the illumination. You got to use the button there. And oh my lord, is that ever a pain in the butt. Installing the new one's not so bad. That's just 2 decals. There's the electroluminescent decal. It's actually 2 pieces if you've never seen one of those or installed it. The electroluminescent backlighting that has the piece that runs in and actually connects to the inverter in here is installed first, and then you stick the actual outside part on that has the writing on it and has the solid green background. But getting the old one off, oh my lord. the old sticker that was on here, this outside part, was so brittle as you started to pull it. There were just I've got pieces all over the place in here. It was like glass just shattering, little chunks of hard brittle plastic just flying all over the place. And then the electroluminescent display that's sandwiched in between the faceplate and the actual outside sticker here. Oh Lord, trying to get all that sticky, gooey residue off of this faceplate. Because if I don't get it off, of course, that'll transfer through the decal. You'd have lumps and bumps, and it wouldn't look right. So, yeah, it took a while getting all that scraped off of there and then get all the glue residue off. So I could get a good bond, because I don't want this thing to fall off. But, yep, so there it is. Like I said, I just wanted to really quick show it. Put back together, set up as it's supposed to be, good working radio, and it actually looks nice now. It doesn't have that nasty brown faceplate decal anymore.